Hi, it's Crazy Astrophysics guy again. Just wanted to give another shout out, hey, to you guys. It is Thursday, October 15th at around about noon. So just wanted to say, hey, what's going on? Yeah. Another country shout out I wanted to say is Bonjour mes amis de français. Suivez-moi s'il vous plaît en YouTube dans l'esprit de Jean Cover. Je m'appelle Jean Cover et j'ai étudié l'astrophysique pour 30 ans, mais je n'ai jamais pas écouté bien. Mais oui, s'il vous plaît, suivez-moi en YouTube. J'aime le français et bonjour mes amis. Okay, and that was a shout out to France. Just wanted to say, hey, love you all. Love you all. You know, I love all my followers. All you guys out there who need science help, just give me a give me a holler. But wanted to clear some things up. I know I had some questions from the last session. Yeah, I am at home right now. It's around noon, but I'll be going to work here pretty soon. So just wanted to give this a quick rundown here. For those of you who are looking at the periodic table and wondering what's up with all the numbers that I had from last time, I think this will actually help. I got my big whiteboard. I finally got it out, yes. But if you look at this, here, I'll give you a little bit of a... This is actually what it is. The top number is the periodic number. The number on the periodic table counts protons. The numbers, when you're talking astrophysically and fusion systems, we're actually talking nucleides. So the nucleides is the isotope. And the isotope numbers is what really counts when you're talking about fusion. Now you can see where I have the parentheses where the complex conjugates go. This is where it breaks down. It goes both ways at the same time. You can have carbon and boron in the same instance, and it breaks down to lithium, for the first complex analysis, it's all hydrogen, all the way until you get to helium-4 and lithium-5, or lithium-6, sorry. And that actually breaks down to lithium-6 and helium-4 as well. So the circles I have up above means that there's fusion and fission going on at the same time. So you can jump back and forth between hydrogen, helium, back to hydrogen, helium, and so on. The same way down here as you have lithium, beryllium, boron, all the way to boron 11. Also down here, it's the same thing. All the way from carbon to oxygen. And what I really wanted to point out with this is that it takes time. As if you're an astrophysicist, you'll admit that volume of one of these stars takes time. It doesn't explode and become a rapid, huge, massive red giant all at the same time. Unless it's starting to burn helium-4. Helium-4 is what makes a red giant a red giant. And these things are massive. I mean, take Betelgeuse for instance. We've actually started seeing Betelgeuse blink. It's getting dimmer and it's getting brighter all at the same time. So, yeah, it's one of those astrophysically things going, what's going on here with Betelgeuse? Betelgeuse has probably, and I'm not saying it has, it probably has gone supermassive, supernova, as it has, and we just don't know it yet. because it is burning out dimmer and dimmer. And it takes so long to get here. The light that we're seeing is from, God, 50 million years? 50 million light years? Now remember, a light year is a measure of distance, not time. And as I said before, time is irrelevant because time is not absolute. It's not like, I met Stephen Hawking at a lecture he was hosting way back in the 1990s at the University of Chicago when he was up there doing a lecture series. He was very, very bright. Yeah, I've had it's been a rough 3 years, I'll tell you right now. With the death of Stephen Hawking in 2018, it's just gone downhill. My close mentor in 2019, and Freeman Dyson just this past February. I'm telling you, it's been terrible. Oh my God, yeah. I've learned some life lessons. Let's just say that. If you got to tell them you love them while they're still here, because life is too short. And this is the point of this whole episode today. Do what you want to do. You live your dreams. You go for it, because life is way too short to be unhappy. I mean, it's way too short to be unhappy. I mean, you can be anything you put your mind to, and I don't care if you're. If you come from poor people, I was middle class. I mean, and it took me all this time to get to where I am. It does take time. It's going to take baby steps, but baby steps are great. Always achieve your goals every day. Achieve something towards your goals, because, for me, it doesn't matter, race, color, religion, you're all a friend of mine, okay? Man, woman, whoever, it comes to me with a question, I'm going to answer it truthfully. I'm going to answer it to the best of my ability, because, like I said, this channel is not for me. It's not to say, hey, how great I am. It's for everybody out there that needs help, that wants to talk about science. Please, I implore you to ask me anything you want to. It's stuff like this. This is, and I'll show you the wide angle here. It's because of stuff like this is what I can do the best. Astrophysics, fusion systems. I remember when I was talking to you guys about iterative functions. I had a whole class on chaos theory, and chaos theory is nothing but iterative functions. So I've done 5,000 hours of iterative function, not consecutively. I haven't done 5,000 hours consecutively. That would be crazy. But yeah, I mean, I've done all kinds of stuff. And when I say I've taken a course in chaos theory, I've taken class after class after class of nothing but chaos. Because in astrophysics, you deal nothing but with chaos, whether it's algebraically, topologically, calculus. I've had I've had calculus 2 and 3, where they do triple integrals with multiple variables, and I took political science because as an undergrad, I took political science. Sorry about that. Yeah, there was some fuzz on the camera, but I took political science because it rounded me out. I could take sample research programs. I could, take 30 data sets randomly, do multiple regression. Oh, this is another point I wanted to point out to you. If you're doing multiple regression, I can't talk here. Doing multiple regression, Excel or anything Microsoft-wise is great because you can put in you can type in at the top what your equation is, take all the 30 sets of data and actually ream it all out. So it's a heck of a lot easier than doing it through like a TI-89 or a TI-84 calculator, because calculators you have to do one sequence at a time. Sometimes you have to redo regressions on calculators, and it's kind of a pain. I've done it before. It's kind of a pain. I really don't like to do it that way. I usually do it through Excel, any kind of Microsoft proportion, data set, whatever it's a lot easier to do it through Excel. But like I'm showing you here with my huge whiteboard, I finally got it out. I'm proud of myself. But yeah, this is what I do. This is how complex my mind is, okay? This is why I call it within the mind of Cover, because I'm always thinking multiple things all at the same time. Even when I'm talking to you guys, my head is going, okay, a squared plus b squared equals c squared. Square root of -1 is I squared is -1, all that. Yes, my mind is going rapid fire all the time. Even, I'll show you how complex this is. I wanted to go to med school when I was a kid. Actually took my MCAT in my grad school years of physics. Took the MCAT, scored so high that they said I should have been in the medical scientist training program. Yeah, MSTP, man. This guy is far out. but yeah, I took the MCAT, had one of the highest scores. I beat several Japanese people too. Not proud of that, but it is what it is. Sorry. Yeah. Nihongo hanashimasu. Oh, gomenasai. But yeah, I did really well on the MCAT. I was going to go to med school until they told me, well, insurance dictates what you can do. And I said, no, I do not want to be oppressed by insurance. I don't want to be oppressed. Sorry about that. Oppressed by anything, because my mind, I can achieve anything as well as you guys can. I mean, this is why I want this channel out there forever, because I want you guys to know it doesn't matter where you come from. It doesn't matter who you are. It doesn't matter what color you are. It doesn't matter anything. What you put your mind to, you can achieve. You can achieve anything in this life. And you can imagine. But back to my complexity, because I can ramble on and on about everything. Back to complexity of my mind. When I was starting out with my fusion, this was way back before I studied all this stuff. I actually called it the gravitational fusion device. That's when, and then most people are going, he called it gravitational fusion? Yeah, that was when we actually thought gravity was the actual fundamental force, believe it or not, back in the 1990s. And for those of you who are getting confused, it's not gravity. It's it's not gravity. I'll tell you that. It's coming out in my book. My book will have it all. Actually, my book will have one chapter dedicated to my dissertation. There's a chapter in there dedicated to Stephen Hawking's dissertation on time. There's a chapter in there dedicated to what I think the closest scientist for quantum mechanics, the best scientist that has ever come close It's not Albert Einstein. It's not Albert Einstein. It's J.J. Thomson. J.J. Thomson, who actually discovered the electron in his lab in England. So, yes, all you English people love J.J. Thomson because I'll actually have a chapter dedicated to him in there, too. He's the actual guy who wrote his dissertation on conductivity of electricity through the expansion of gases. It was awesome. It was huge. I read that. I learned something every day from books from the 1800s because, sometimes we do go astray in science. It happens, and we got to go back. Just like I do admit time travel is possible. I'll actually show you proof of my experiment that's been ongoing for a long, long time. I'll show you that next time. But what I want to talk to you about the complexity of my mind. When I was doing the schematic for my fusion device way back in sophomore year of high school, I was actually wanting to go to med school so I could start a biomedical hospital. And I've actually approached some people, and I can't tell you where this is at, but I actually got a hold of people for an abandoned mall and tried to get them, tried to see if they wouldn't let me do an experimental biomed hospital. We could have had a biomed hospital where I'm at. So, yeah, and they were like, well, when they found out it was me, they raised the price, and I was like, shoot. So yeah, that wasn't the exact word that I used, but as you guys probably know, but yeah, I wanted to start a biomedical hospital, use the elements that I don't care what they call it, artificial. It wasn't nothing artificial about this star. Anything with helium that you're going to be fusing together, it's natural. Natural fusion capabilities. You extract the elements from the natural fusion capabilities, and you do not engineer. Now, I want to, all you Harvard people, all you Harvard intellectuals, I'm talking to you guys right now. You do not tissue engineer anything. I mean, you want this all to be natural tissue infusion. I call it tissue infusion because once you supply stem cells to a certain, and I'm talking genetically here, if you naturally introduce stem cells to a certain, and yes, I'm taking blood type, everything into consideration here. Once you introduce stem cells to a certain tissue, signal processing, I'm talking quantumly signal processing. This is where quantum biology is actually starting. This is where CRISPR, thank God for the ladies that have developed CRISPR. Not to deny anything about whether, not to deny anything about genetic mutations. When we call genetic mutations, some mutations are great. Some mutations aren't so great. It's another whole complex conjugate. We're talking about complex conjugates here. Everyone is great. Everyone is here for a purpose. I'm not talking about genetic mutating anything as far as monster-wise or Frankenstein-wise or anything like that. I'm not talking about that. I'm talking about just natural tissue infusion. I wanted to push pico-endoscopic surgery. Now, when I'm talking pico-endoscopic, I'm talking about making an incision about 10 nanometers of a pin, inserting the tissue, because this tissue is really small. Our bodies actually heal itself, really. I mean, after everything that I've learned throughout my entire life, our bodies actually heals itself rather well, actually. Now, if you could go in with a nano, and I'm talking nanotechnology here, you go in with a needle with a little, very little, I'm talking pinchers. You go in with a needle and you take, and if you can find cancer out right at the second it happens, it's best, because you can take that cancerous cell out of there and put in stem cells. Not 99% of the time, I'm talking statistically here, it's actually been proven statistically significant that in 60% of the cases where you infuse tissue on a certain tissue, I'm talking muscle tissue, skin tissue, epidermic tissue, actually 60% of the time, you will actually grow healthy tissue. The healthiest tissue I can actually incur. 40% of the time, you might find it to grow another cancerous cell. If you find that out, the sooner the better. I tell you that. You can't wait until it's like this big or a tumor or baseball size. No, you don't want to wait that long. If you can find cancer out at the cellular level, and I'm talking cellular level, where we're talking, mitochondrial, DNA, RNA, and everything else here. You can take a cancerous cell out and place with another stem cell. It'll be fine. I mean, 60% of the time, which is awesome. I think that's great. That's a heck of a lot better than 50%, which is flip a coin. But yeah, things are possible. Things are possible that you could never imagine. I wanted to build a facility just like that, where we could do natural tissue infusion is what I called it. Yes, I'm actually expressing my own work here on YouTube. This is great. I love it. And I employ, if anyone has the means to do this, please do so. Because, and there's ways we can actually engineer, nanotechnological wise, we can actually engineer anything to do anything. Like I said, needle point, get in, take it out, needle point in, put in the natural tissue infusion, let it do its work. I was wanting to do that. So we'd go from star element fusion. We'd extract the elements out of the gravitational fusion device. You extract it out of that. Like I say, it's very fine-tuned, but you can natural elements in, you're going to get natural elements out. That's, you can tell me I'm crazy all you want to, but I am a full advocator of that. I would have loved to have seen that happen in my time. I mean, I'm still here, so I'm hoping within the next 60 years, I'm talking to you people in the future now, within the next 60 years, I'm hoping that'll catch on. So, so we go from astrophysics to genetics to, whatever, to, medical treatment of the future. I want to see that. So, before I get off of here, I wanted to say, love you guys for following me. Like I say, I ramble, sorry about that, but that's everything pretty much that has been in my mind for a long time. So next time I will actually talk about my experiments that I'm wanting to get done. Yeah, I'll be talking about my own work as well, about the redesign of the fusion generator the fusion device that I want to build, the big huge Tesla coil that I want to build as well, the charge density experiment that I'm still writing up. I'm still writing up about that charge density experiment, and yeah, that's been several years in the making. I've started writing that up in 2015, so it's been 5 years. So yeah, I want to get that going. Yeah, I'll talk about all that, down to materials that I need. But that'll be next time. I'll be talking about that. But yeah, there's a lot more. So I just wanted to say, hey, it's been great talking to you guys. Hopefully I'll be able to do this for infinite number of years. I hope so. But yeah, if you guys, I'll be looking at the comments. I'll be looking at the questions. I wanted to address a certain issue. That the body of water that we have can't talk. That we have on the terrestrial body of water here on Earth. Yeah, it does slow our motion down. Think of it as a tub of water. If you were transporting a tub of water, wouldn't that slow you down? Even when you're stopping and going from here, when you're stopping at a stoplight, that tub of water is going to move with you. The principle is the same for here, for on Earth. It does slow our rotation down. However, it doesn't slow it down all that much. But our moon doesn't help either. So, actually, our moon actually helps us in ways that we will never know. Because it wouldn't be possible for us to be here if it wasn't for it. Because if it wasn't for our moon, we wouldn't have sidereals, we wouldn't have tides, we wouldn't have all kinds of stuff. Our moon actually helps us not slow down, because like I said, when you're moving a tub of water, that has a major effect on how fast you can accelerate and how slow you have to decelerate. Same way with the rotation of the Earth. The Earth is actually spinning really, really fast. The body of water, if we didn't have water, we could actually speed up. But, yeah. Water and the moon actually works as a transition. So if it wasn't for our water, we'd be going a lot faster. We would go, our days would probably end up being like, I can't really say for sure, but our days would probably end up being 15 hours instead of 24 if we didn't have water. So yes, water does slow our rotation down quite a bit. But like I say, we're still moving pretty fast, even though we don't know it or we don't notice it right away. Yeah, moon is there for a reason. Water is on Earth for a reason. Yeah, even if it was frozen like Mars, yeah, Mars actually is a little bit slower, but that's due to another reason, and I'll get to that in another time. So I wanted to say, love you guys. Always live 5 iterations above the norm, and I will catch you guys later. All right, love you all. Peace.